Hello everyone, today's topic, volume of cones. Our essential questions: how can we find the volume of a cone? And how can we find missing dimensions of a cone when we're given some information? Alright, let's get to it. First off, we have our volume of a cone, like we've kind of talked a little bit about in class, is 1/3 pi r squared h. You may notice that a cone is 1/3 of a cylinder with the same height. Here we have our cone with the radius of the circle given, that's our r, and our height is just from the base to the top, that is our h. These steps are going to be very similar to solving for the volume of a cylinder. Step 1, identify the radius and height of the cone. Step number 2, substitute in your radius and height into the formula. And step 3, calculate it up. All right, let's get to some examples. Find the volume of a cone. Here we have example 1. I notice that the radius of this cone is 3, and the height of the cone is 10. So we're going to identify those. Next, you'll see that we've substituted those into the formula, 1/3 pi r squared. Instead of r, we put 3. And instead of h, we put 10 for the height. Calculating that out, we can use our take care of our exponent first. 3 squared is 9. 3 times 3 is 9. And then if we put this into our calculator, 1/3 times pi times 9 times 10, we will end up with a volume of 30 pi. Here we're leaving pi in our answer. Let's look at example number 2. In this example, it looks like we have a diameter of 6, which means for our radius, we're going to have to take only half of that, which would be a radius of 3. And our height, even though it's tipped over, is from the base to the point, which is 6. So we have a radius of 3, a height of 6. Putting that into our volume formula, we have 1/3 pi. Instead of r, we have 3 squared. And instead of h, we have 6 for our height. If we take care of that exponent first, 3 times 3 is 9. That's that 3 squared. And then we have 1/3 pi times 9 times 6. If we calculate that out, we're going to get a volume of 18 pi. All right, I'm going to give you a second to try this one down here. But instead of using pi in your answer, this time I want you to use 3.14 and round to the nearest tenth. Try finding the volume of this cone now. All right, let's see how you did. Looks like our radius is 10 and our height is 20. Whoops. Wrong button. Radius is 10, height is 20. If we plug that into our volume formula, we should have 1/3. Instead of pi this time, we use 3.14. Instead of r, we have 10. Instead of h, we have 20. We can square that 10 to get 100. Everything else is the same. And if we calculate that out using our calculator, we'll get about 2093.3, rounding to the nearest tenth. Okay, flip your page over, and we're going to take a look at the steps to find missing dimensions of a cone. So step 1, identify the information we have. Cones, we can have radius, height, or volume. Use those to substitute what you know into the formula and then solve for the missing variable, just like we did with cylinders. Let's take a look at our couple examples here. So a cone has a radius of 3 units. So that cone has a radius of 3 units. We've identified our radius here. We also have a volume of 60 pi units. So when we and they're asking us what is the height. So when we substitute into our formula 1/3 pi r squared h, we have our volume of 60 pi equals 1/3 times pi times our radius squared, that's 3 squared, times h. Now what we want to do is just slowly take care of everything and get that h isolated. So we have 60 pi equals 1/3 times pi, and 3 squared, 3 times 3 is 9. H, and I'll just put some dots in there so we know we're multiplying. And now you have a couple ways to go about this. We can take care of that 1/3 and that 9, but I'm just going to start just because it makes things look a little easier for us, I'm going to divide by pi and cancel those pi's out. Then we're going to be left with 60 equals 1/3 times 9 times h. And we have a couple options here. One, we can kind of simplify this 1/3 times 9, or we can divide and multiply everything over. I'm going to do the second choice. I'm going to start by multiplying both sides by 3, because that will cancel out my 1/3. Remember, that fraction is dividing, so that'll cancel out that 1/3 if I multiply by 3. And 3 times 60 is going to be 180 equals 9h. Then all we have to do is divide by 9 and divide by 9, and that'll give us a height of 180 divided by 9, which is 20. So we found our height, h equals 20. Let's try an example where we have to find the radius. So here we have a height of 12 units. We have our height given there. We have a volume of 144 pi units right there. And like I said, they are asking us what is the radius. So using our formula, instead of volume, we put 144 pi equals 1/3 pi r squared, we don't know the radius, times the height, which is 12. If we want to solve from here, now we're trying to isolate the r, or the r squared. So I'm going to start by dividing by pi. Divide both sides by pi. We know those pi's are going to cancel each other out, leaving us with 144 equals 1/3 r squared times 12. That's a 1/3 right there. And then, let's say we want to cancel this 1/3 out. Well, we can multiply this side by 3, multiply this side by 3. My 1/3 and my 3 are going to cancel out. And on the left, we have 3 times 144, which is 432, equals r squared times 12. We can divide that 12 out, because we want to get the r by itself. So if we do 432 divided by 12, it looks like we're going to get 36 equals r squared. Then we want to ask ourselves, okay, what times itself, what squared will equal 36? What do you think r is, the radius? Okay, if you said radius was 6, you'd be absolutely right, because 6 squared, 6 times 6 is 36. So we've plugged those in and slowly solved and got r isolated all by itself. Okay, last thing here, looking at parts or multiples of a cone example. An ice cream store has a small cone and a big cone. The big cone has a radius of 4 centimeters. And I'm just going to underline that because that seems important. So a radius of 4 centimeters. It has a height of 20 centimeters. And it says the small cone has the same radius, but only half the height. That's interesting. So the small cone has the same radius, but half the height. And they're asking, what is the volume of the small cone? So to start things off, let's find the volume of the big cone. So use your formula. I want you to try to find the volume of the big cone using a radius of 4 and a height of 20. Try to do that now. Okay, when you plug those into the formula, you should have got 1/3 times 3.14. I'm using 3.14 because we're rounding to the nearest tenth instead of pi. If you left pi for now, that's okay. Our radius was 4, so that's 4 squared, times our height, which is 20. And if we calculate all that out, we should have got 334.9 cubic centimeters. So now that we know what the volume of the big cone is, I want you to think about what would you do to find the volume for the small cone if we know that this is only half of the height. So we have half the height. What are you going to do to find the area, the volume of the small cone? What do you think? Okay, if you said multiply by a half, you would be correct because everything else is the same here, 1/3 pi r squared, but h is only half the size, so we can multiply that by a half. And if you do that, you're going to end up with 167.5 cubic centimeters. Of course, if we had this question, you would totally be able to say, let's just take the radius of 4 and a height of 20, take that height of 20 and cut it in half to 10, and we could have solved directly using a radius of 4 and a height of 10. Either way, should have ended up with the same answer. Okay, take a few minutes, write that summary, make sure you're answering those essential questions at the top. I hope this video was helpful.